Preparing for a DevOps engineer interview. You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What does a good CI/CD pipeline look like for a production service? A good CI/CD pipeline converts every code change into a safe, traceable production candidate. I would start with a Git trigger, build the artifact once, run unit and integration tests, scan dependencies and containers, then promote the same artifact across environments. Deployments should include approvals where needed, automated smoke tests, metrics checks, and rollback hooks. The key principle is repeatability. Production should be a controlled promotion, not a manual rebuild. While answering, focus on source control triggers, build isolation, automated tests, security scans, artifact versioning, deployment stages, approvals, rollback strategy, and observability after release. Question 2. How do Docker containers differ from virtual machines? Containers package an application with its dependencies, but share the host operating system kernel. Virtual machines include a full guest operating system on top of a hypervisor. That makes containers faster to start, lighter, and easier to scale, while VMs provide stronger isolation and broader OS flexibility. In practice, I use containers for microservices and CI workloads, but still use VMs when isolation, legacy OS requirements, or compliance boundaries matter more. Make sure to cover kernel sharing, isolation boundaries, startup time, image size, resource efficiency, security considerations, and when virtual machines may still be preferred. Question 3. Explain the main Kubernetes components and how a request reaches a running pod. Kubernetes has a control plane that decides desired state and worker nodes that run workloads. The API server is the entry point. The scheduler places pods. The controller manager reconciles state, and etcd stores cluster data. On each node, kubelet manages pods, and kube-proxy handles service networking. A user request typically reaches an ingress controller, maps to a service, then selects healthy pod endpoints using labels. Kubernetes keeps reconciling if pods fail. In your answer, talk about control plane components, worker nodes, kubelet, scheduler, API server, services, ingress, kube-proxy, labels, selectors, and pod networking. Question 4. How would you troubleshoot a Kubernetes pod stuck in CrashLoopBackOff? I start by confirming the failure pattern with kubectl describe pod and checking events for image, scheduling, or probe errors. Then I inspect current and previous logs using kubectl logs-previous because CrashLoopBackOff often hides the real startup failure. I verify environment variables, mounted secrets, config maps, command arguments, and resource limits. If liveness probes are too aggressive, the app may be killed while starting. Finally, I compare against the last known good deployment. Be sure to mention checking pod events, logs, previous container logs, probes, resource limits, environment variables, image issues, config maps, secrets, and recent deployment changes. Question 5. What is infrastructure as code? And why is Terraform commonly used? Infrastructure as code means defining infrastructure in files instead of creating resources manually through consoles. Terraform is popular because it is declarative, cloud-agnostic, and provider-based. I can define networks, clusters, databases, IAM policies, and outputs, then review changes using Terraform plan before applying them. State tracks real infrastructure, so teams must protect it with remote backends and locking. The main benefit is reproducible environments with peer review and audit history. While answering, cover declarative configuration, version control, repeatability, state management, providers, modules, plan and apply workflow, drift detection, and collaboration benefits. Question 6. How do you manage Terraform states safely in a team environment? Terraform state is sensitive because it maps configuration to real resources and may contain secrets. In a team, I store it remotely, for example in S3 with DynamoDB locking or Terraform Cloud, and enable encryption plus strict IAM access. Locking prevents two engineers from applying conflicting changes. I separate state by environment or domain to reduce blast radius. If drift occurs, I use plan and import carefully, rather than manually editing state, unless it is unavoidable. Make sure to discuss remote state backends, locking, encryption, access control, state file sensitivity, workspaces or separate states, drift handling, and avoiding manual state edits. Question 7. What is the difference between Ansible, Terraform, and Kubernetes? Terraform provisions infrastructure, Ansible configures systems, and Kubernetes orchestrates containerized workloads. Terraform is ideal for creating cloud resources like VPCs, load balancers, and clusters. Ansible is useful for installing packages, managing files, and enforcing server configuration over SSH. Kubernetes keeps applications running through deployments, services, and controllers. They overlap slightly, but I prefer clear boundaries. Terraform builds the platform, Ansible configures hosts if needed, and Kubernetes manages application lifecycle. In your answer, compare provisioning, configuration management, orchestration, declarative versus procedural behavior, idempotency, common use cases, and how these tools can work together. Question 8. How would you design a blue-green deployment strategy? Blue-green deployment keeps two production-ready environments. Blue serves current traffic, green runs the new version. I deploy to green, run smoke tests, validate metrics, then switch traffic using a load balancer, service mesh, or DNS with low TTL. Rollback is fast because I can point traffic back to blue. The tricky part is data compatibility, so database migrations must be backward compatible. It costs more infrastructure, but reduces release risk significantly. Be sure to cover two production-like environments: traffic switching, database migration concerns, health checks, rollback speed, infrastructure cost, DNS or load balancer routing, and validation steps. Question 9. When would you choose canary deployment over rolling deployment? I choose canary deployment when I want to expose a release to a small percentage of traffic before full rollout. Rolling deployment replaces instances gradually, but every user may eventually hit the new version without deep validation. Canary lets me monitor error rate, latency, saturation, and business metrics for a controlled slice. If signals look bad, I stop and roll back quickly. It needs strong observability and traffic control, but gives better production confidence. While answering, explain progressive traffic shifting, blast radius reduction, metrics-based promotion, user segmentation, rollback triggers, rolling deployment limitations, and automation requirements. Question 10. How do you handle secrets in CI/CD pipelines and production environments? Secrets should never live in source code, Docker images, or pipeline logs. I use a secret manager such as AWS Secrets Manager, Vault, Azure Key Vault, or GCP Secret Manager, with access controlled by workload identity or short-lived credentials. In CI/CD, I mask variables, restrict permissions, and avoid printing commands that expose tokens. In Kubernetes, basic secrets are only base64 encoded, so encryption at rest and RBAC matter. Rotation and audit trails complete the practice. Make sure to mention avoiding hard-coded secrets, secret managers, encryption, least privilege, rotation, masking logs, short-lived credentials, Kubernetes secrets limitations, and auditability. Question 11. What monitoring and alerting would you set up for a microservice? For a microservice, I monitor the golden signals: latency, traffic, errors, and saturation. I add application metrics like request count by endpoint, dependency failures, queue depth, and database latency. Logs should be structured with correlation IDs, while traces show where time is spent across services. Alerts should map to user impact, not every noisy metric. I prefer SLO-based paging for high error rates or latency, with dashboards for diagnosis. In your answer, include golden signals, read or use metrics, logs, traces, dashboards, SLO-based alerts, dependency monitoring, alert fatigue, and incident response integration. Question 12. How would you investigate high CPU usage on a Linux server? I first check load average and CPU distribution using top, htop, mpstat, or SAR. If one process dominates, I inspect its command, threads, logs, and recent deployments. High user CPU points to application work. High system CPU may suggest kernel, network, or disk-related overhead. In cloud environments, I also check CPU steal. For containers, I verify limits and throttling. The fix depends on cause, rollback, scale out, tune code, or adjust resources. Be sure to cover top or htop. Process identification, load average, CPU steal, system versus user CPU, logs, recent changes, profiling, containers, and remediation options. Question 13. Explain how DNS works and why it matters in DevOps. DNS translates names into records like IP addresses, aliases, or verification values. A client usually asks a recursive resolver, which follows the hierarchy to authoritative servers and caches the answer based on TTL. In DevOps, DNS affects deployments, failover, service discovery, certificates, and incident recovery. Low TTL helps traffic shifts, but increases query load. I troubleshoot with dig, NSLOOKUP, and trace options, checking the exact resolver path rather than assuming propagation is instant. While answering, discuss recursive resolution, authoritative servers, records like A, CNAME, TXT, TTL, caching, propagation, service discovery, failover, and troubleshooting tools. Question 14. How do you make a cloud application highly available? High availability starts by removing single points of failure. I run stateless application instances across multiple availability zones behind a load balancer with health checks. Databases need replication, automated failover, backups, and tested restore procedures. I also use autoscaling, resilient queues, retry policies with backoff, and circuit breakers for dependencies. Observability is part of availability because failures must be detected quickly. Multi-region can improve resilience, but it adds data consistency and operational complexity. Make sure to cover multi-AZ architecture, load balancing, health checks, stateless services, database replication, autoscaling, graceful degradation, backups, monitoring, and avoiding single points of failure. Question 15. What is GitOps, and how is it different from a traditional deployment pipeline? GitOps uses Git as the source of truth for infrastructure and application desired state. Instead of a pipeline pushing changes directly into a cluster, a controller such as Argo CD or Flux pulls from Git and reconciles the live environment. That gives auditability, peer review, easy rollback through commits, and drift detection. Traditional CI/CD still builds and tests artifacts, but GitOps makes deployment more declarative and controlled, especially for Kubernetes-heavy platforms. In your answer, talk about Git as source of truth, declarative desired state, pull-based reconciliation, auditability, rollback through commits, Argo CD or Flux, and drift correction. Question 16. How would you secure a Docker image before deploying it? I secure Docker images by starting with a minimal trusted base, pinning versions, and using multi-stage builds so build tools do not ship to production. I avoid copying secrets, run the container as a non-root user, set read-only file systems where possible, and scan for vulnerabilities in CI. I also generate SBOMs and sign images for supply chain trust. Security does not stop at build time. Runtime policies and least privilege are equally important. Be sure to mention minimal base images, vulnerability scanning, non-root users, pin versions, multi-stage builds, secret avoidance, image signing, SBOMs, and runtime security. Question 17. What happens when you increase replicas in a Kubernetes deployment? When I increase replicas in a deployment, Kubernetes updates the desired state. The deployment controller manages the replica set, which creates additional pods. The scheduler places those pods on suitable nodes based on resources, affinity, taints, and constraints. Once containers start and readiness probes pass, the pods become service endpoints and receive traffic. If the cluster lacks resources, pods remain pending. Manual replica changes work, but horizontal pod autoscaler can adjust replicas automatically from metrics. While answering, cover desired state change, replica set behavior, scheduler placement, pod creation, readiness, service endpoints, load distribution, resource constraints, and auto-scaling relationship. Question 18. How do you approach incident response during a production outage? During an outage, I focus on mitigation before perfect root cause. First, I assess severity, declare an incident if needed, assign roles, and open a communication channel. Then I check dashboards, logs, recent deployments, and dependency health. If a rollback or traffic shift can restore service safely, I do it quickly. I keep a timeline of actions and decisions. Afterward, I run a blameless post-mortem with concrete fixes, owners, and deadlines. Make sure to discuss severity assessment, communication, ownership, mitigation first, logs and metrics, rollback decisions, timeline tracking, postmortems, and preventing recurrence. Question 19. What is the difference between readiness and liveness probes in Kubernetes? Readiness probes decide whether a pod should receive traffic. Liveness probes decide whether Kubernetes should restart a container. For example, if an app is still warming cache, readiness should fail so the service avoids routing requests to it. If the process is deadlocked, liveness can trigger a restart. A common mistake is using the same aggressive endpoint for both. Bad probes can cause cascading failures, so thresholds and timeouts must match real startup behavior. In your answer, explain traffic eligibility versus restart decisions, startup behavior, failure consequences, probe types, common misconfigurations, and how probes affect rolling deployments. Question 20. How would you implement disaster recovery for a critical service? Disaster recovery begins with clear RTO and RPO targets. RTO defines how quickly the service must recover, while RPO defines acceptable data loss. I would design backups, replication, infrastructure automation, and runbooks around those numbers. For critical systems, that may mean multi-AZ databases, cross-region backups, or warm standby environments. The most important practice is testing restores regularly. Untested backups are only hope, not a recovery strategy. Be sure to cover RTO, RPO, backup strategy, restore testing, multi-AZ or multi-region design, data replication, runbooks, automation, monitoring, and periodic DR drills. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.